Hello everyone, my name is Jian from SMA 1 IPA A, and in this video, I'm going to discuss about matter. Matter is classified into two, pure substance and mixture. Pure substance is divided into two, element and compound. Element is consists of metal, non-metal, and metalloid, while in compound there is organic and inorganic. Organic consists of acid, base, and salt, while in inorganic there is aliphatic and aromatic. Mixture is divided into two, homogeneous and heterogeneous. Homogeneous consists of solution, and in heterogeneous consists of suspension and colloid. First, I'm going to discuss about the different types of matter. Second, I'm going to discuss about the different types of pure substance. Third, I'm going to discuss about the different types of elements. Fourth, I'm going to discuss about the different types of compound. Fifth, I'm going to discuss about the different types of mixture. And lastly, I'm going to discuss about the molecular movement. Different types of matter is divided into two, pure substance and mixture. Pure substance is a matter having definite composition and distinct properties, while mixture is a combination of two or more pure substance, for example, jelly beans. Next is different types of pure substance. Pure substance is divided into two, element and compound. Element is a substance that cannot be decomposed into simpler substance, and it is compound of one kind of element, while compound is a substance that is made of two or more elements, thus composed of two or more kinds of atoms. Different types of elements consist of three, metal, non-metal, and metalloid. Metal is a matter having definite composition and distinct properties. Non-metal is a poor conductor of heat and electricity, while metalloid is an element that exhibits both the properties of a metal and a non-metal. Then we have the different types of compound. First, we have the organic compound. It's a compound consisting of chains or rings of hydrocarbons. There are two types of organic compound. The first one is aliphatic organic compound. It's an organic compound without any benzene ring, while aromatic organic compound is an organic compound consisting of benzene ring, which naturally gives strong scent. The second one is inorganic compound. There are three types of inorganic compound: acid, base, and salt. Acid is a compound that produces hydrogen ion when diluted in water. Base is a compound that produces hydroxide ion when diluted in water, while salt is a compound that consisting of metallic and non-metallic ions. Different types of mixture. In different types of mixture, there is homogeneous and heterogeneous. Homogeneous is a mixture wherein only one phase is made visible, while heterogeneous is a mixture wherein two or more phases are made visible. There are three types of mixture, and that is solution, suspension, and colloid. Solution is a type of mixture whose particles are too small to be seen and to remain suspended. Suspension is a type of mixture whose particles are large enough to be seen and to remain suspended. And lastly is colloid. It's a type of mixture whose particles are too small to be seen but large enough to remain suspended. Molecular movement. In molecular movement, there is solid, liquid, and gas. Solid is a state of matter with a definite shape and volume. The molecules of a solid is very close. Next is liquid. Liquid is the state of matter with a definite volume, but not a definite shape. The molecules of a liquid are free-flowing and farther apart than those of a solid. Then lastly, we have gas. Gas is the state of matter that does not have a definite shape or volume. It is more free-flowing than a liquid, and its molecules are very, very far apart. Instead of matter, there is plasma and Bose-Einstein condensate. Plasma. At the very high temperatures of stars, atoms lose their electrons. The mixture of electrons and nuclei that result is the plasma state of matter. Bose-Einstein condensate or BEC. This state of matter is a new addition to the crew. It all starts when the atoms start to get cold, really cold. When the atoms get cold, they get closer and begin to clump up. When the atoms clump up, they become one big blob that all look the same. Here are the examples of post-instant condensate. Diffusion. Diffusion is the movement of particles from a region with higher concentration to a region with lower concentration. Osmosis. Osmosis is the movement of water molecules from a region with higher concentration of water to the region with lower concentration of water. Here are the examples of diffusion and osmosis. Law of diffusion of particles. Graham's law by Thomas Graham states that at a constant temperature and pressure, the rates of diffusion of particles that are inversely proportional to the square root of their molecular masses. And based on the law, we got the equation right here. For example number 1, the average speed of a nitrogen gas molecule is 515 meter per s. What is the average speed of hydrogen gas and a neon atom? Given the molecular mass of nitrogen is 14 times 2 is equal to 28 gram per mole. Then the molecular mass of hydrogen is 1 times 2 equal to 2 gram per mole. Next, the molecular mass of neon is 20 gram per mole. And from the question, we also know that the rate of diffusion of nitrogen is 515 meter per s. And we're going to find the rate of diffusion of hydrogen gas and a neon atom. First, we're going to write our formulas down. Then we're going to plot in the given to the formula. Cancel gram per mole out. The result of square root 2 for 28 is 0.27. First multiply and we got the result 515 meter per s equal to 0.27 rate of diffusion of hydrogen divided by 0.27. Cancel 0.27 out. We're going to divide 515 by 0.2 and we got the result 9007.41 meter per s. Next, we're going to find the rate of diffusion of neon. First, we're going to write our formulas down. Cancel gram per mole out, and the result of square root of 20 divided by 28 is 0.85. Cross multiply. In order to find the rate of diffusion of neon, we need to divide it by 0.85. Cancel 0.85 out. Then we're going to divide 515 with 0.85. And we got the result 605.88 meter per s. Next, we have methods of separating mixtures. First, we have filtration. Filtration is the use of layers of filters to separate solid substance from liquid. Decantation separates liquid from the residues using glass rod. Evaporation to dryness, letting the liquid to evaporate until the solid components are left. And lastly, we have configuration. It's the use of centrifuge to separate mixture by density difference. Here are the examples of filtration, decantation, evaporation, and centrifugation. Simple distillation is a method of separating liquid and solid in a solution in which the liquid is the solvent while the solid is the solute. Then we have fractional distillation. It's a method of separating a liquid from another liquid by means of fractionating column. Using separating funnel is used to separate invisible liquid. And lastly, we have using magnet. It's used to collect metals from the mixture of solids using magnetism. Here are the examples of simple distillation, fractional distillation, separating funnel, and using magnet. Using suitable solvent is the use of solvent in which only one solid is soluble to it while the other is insoluble. Next, we have crystallization. Crystallization is used for obtaining a pure solid sample from a solution. Chromatography is the method of separating two or more components that dissolve in the same solvent. Here are the examples of using suitable solvent, crystallization, and chromatography.
Here are some procedures in separating mixture. The first one is simple distillation.
When performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture, which is to be distilled. The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled, and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into the condenser, they will be cooled and will liquefy. The liquid droplets, called the distillate, run down the condenser and are collected in a receiving flask. A liquid can be easily separated from non-volatile contaminants by using a simple distillation apparatus such as this one. Since the non-volatile components in the distillation flask will not evaporate, the vapors and the resulting condensate will be pure.
Next, we have a video on crystallization and how it works.
Take 100 milliliters of water in a beaker and heat it on a Bunsen burner. When water begins to boil, add about 2 milliliters of dilute sulfuric acid and then a spoonful of CuSO4. Stir the contents with a glass rod. Stir it continuously and add more impure copper sulfate until no more of it dissolves. Fasten a thread in the middle of a wooden stick and suspend in a glass. Stop heating and pour the saturated copper sulfate solution in a glass. Place the glass aside and cover the beaker with a cardboard. Leave the setup for 24 hours. After 24 hours, you will find big blue crystals of pure CuSO4 at the base of the beaker. Then remove the crystal from the glass and dry in warm air.
That's the end of the discussion about matter. Thank you so much for watching and have a nice day.